Today's lesson is on exponents raising a power to another power. As usual, we have a video guide to go along with this lesson. If you haven't already printed the video guide, go ahead and pause the lesson, print the video guide, and then come back and you can work out the problems with me. So power to a power just means that you have something that's raised to an exponent, but then you're raising it to another exponent. So something raised to a power and then raising that to another power, hence the name power to a power. Okay, so what we're going to do is take a look at an example together. We're going to expand the problem, a lot like what we did for multiplying and dividing exponents. And once we expand the problem, we'll actually be able to see what's happening a little bit better, and that'll help us come up with a rule for power to a power. That way we don't have to expand every single problem that we come across. Okay, so taking a look at this first problem, we have x to the 5th power, and we're raising that entire term to the 3rd power. So we're raising something that's to the 5th power, we're raising it up to the 3rd power. Now remember, an exponent means you're multiplying that by itself that many times. Okay, whatever the exponent is, that tells you how many times to multiply it by itself. So looking at this problem, it's saying that I need to take x to the 5th and multiply it by itself 3 times. So that means I'm multiplying x to the 5th times x to the 5th times x to the 5th. Multiplying it by itself 1, 2, 3 times because my power is 3. Okay? Now I can expand this even further and say, well, x to the 5th power means that I'm multiplying x by itself 5 times. So I can essentially make each of these parentheses 5 x's. 3, 4, 5. That's the first set of parentheses. The second set of parentheses would be 5 more x's. 3, 4, 5. And the third set of parentheses would again be 5 x's. 4 and 5. All right. So if I take a look at this, I have 5 x's here, 5 x's here, and 5 x's here. All right. So 5, 10, 15 x's all together. So my answer for this would be x to the 15th if I simplify it all the way down. Now obviously we don't want to do this every single time we do a power to a power problem. That would take a long time and it's a waste of time. All right, so let's see if we can find a shortcut. So looking here, we have x to the 5th and we're raising it to the 3rd power. Going from here to here, do we see a relationship between these two exponents and the exponent of our answer, 15? Well, I have 5, I have 3, and I want that to equal 15. Well, we did addition when it was a multiplication problem. We actually added the exponents, 5 plus 3. But 5 plus 3 would give me 8, not 15. For division, we actually subtracted the exponents, 5 minus 3, but 5 minus 3 is 2, even further away from 15. Looking at this, if I use multiplication, 5 times 3, that would give me 15. So that's our shortcut. We can actually multiply as long as we're raising an exponent to another exponent, power to a power. So our rule for power to a power is that we are going to multiply the exponents. Okay, so that will be our shortcut today. Anytime you have an exponent raised to another exponent, to get rid of those parentheses and to simplify it as far as we can just multiply the exponents, and that's going to make the problem a lot easier. It's going to save us a lot of work instead of expanding it every single time. So this time we're going to go ahead and do a few examples of that together. So for problem number 3, we have our parentheses, and inside we have 4x to the negative 6, y to the negative 3rd, and we're raising that to the 5th power. Now we need to understand that everything that's inside that set of parentheses is being raised to the 5th power. So that means the 4, the x, and the y all need to be raised to that 5th power. I like to think of this as kind of like the distributive property, okay? All of them are going to get that 5th power, so we need to distribute that 5th power to every single exponent in the problem, all right? Now, 4 looks like it doesn't have an exponent, so I could leave it as just 4. But remember, everything has an exponent, even if it's not written. So the exponent for 4 is actually a 1. They just don't write it in. So I'm going to go ahead and write it in so I don't forget that I need to distribute that 5 to the 1 as well as the -6 and the -3, okay? So we're actually going to multiply all 3 exponents by 5. That's our shortcut. Remember, multiply the exponents when you have power to a power. So I'm going to multiply 1 times 5, so I get 4 to the 5th power. I'm going to multiply -6 times 5, so I will get x to the -30th power. Remember, different signs, it's going to be negative when you multiply. And for y, -3 times 5 is -15. Again, as long as the signs are different from multiplication, it's going to be negative. Doesn't matter which one's bigger. At this point, I'm going to go ahead and write my answer as a fraction. Remember, positive exponents go in the numerator, negative exponents go to the denominator. So, fraction, 4 to the 5th power. That is a positive exponent, so 4 to the 5th goes in the numerator of my fraction. X to the -30th, negative exponents go to the denominator, so that becomes x to the 30th. Y to the -15th, again, negative exponent goes to the denominator and becomes y to the 15th. Now, most of the time, once we've written our answer as a fraction, we're finished. However, we can simplify a little bit further. 4 to the 5th power, I can actually work that out, okay? So, I can do 4 to the 5th power. You can multiply 4 by itself 5 times. However, that gets a little tricky. If you have a calculator, I would suggest that you use it. Now, if you have a calculator, just like the ones that we have in our classrooms, the ones that are used for the test, I'm going to go ahead and show you how to plug in 4 to the 5th in your calculator. So what you would do is you would hit 4 first. Then you will see a button along the left-hand side. It looks like a little roof or an arrow pointing up. It's called the caret key. Don't ask me why they call it the caret key, but that's what it is. All right, and it just means that the very next number that you enter will be the exponent, okay? So hit 4 first, then hit this caret key, and then hit 5 as your exponent. After that, just hit enter, and you should get 4 to the 5th power in your calculator, which is 1024, okay? So this simplifies to 1024 at the top of our fraction, okay? We simplified 4 to the 5th, we leave it where it was located at the top, but we write it out as the full number now, 1024. And then the denominator, x to the 30th, y to the 15th, that stays the same. So the only thing I changed was that 4 to the 5th power, okay? Because I can actually multiply that out, I'm going to go ahead and do that, and I get 1024. And that's our answer for number 3. Now, for problem number 4, we have x to the -1st and y to the -3rd, and we're raising that all to the 2nd power. Okay, so I don't have a number out front. It's really not important, okay? I don't have to worry about it. I can put a 1 there if I want to, but if you think that through, 1 to the 2nd power is still just 1. So it's always going to be 1. So we don't have to really worry about that number out front if it's not there. Here we had a 4, so we had to actually work it out. We came up with 1024 in the end. All right, but when the number is missing, you can just leave it off, okay? So we're gonna go ahead and distribute our exponent of 2 to the -1 and to the -3. So we're gonna have x, and we multiply exponents for power to a power. So I'm gonna take -1 times 2, and that gives me -2. And then for y, I take -3 times 2, and that gives me -6. My next step at this point is to write it as a fraction, okay? So I need my fraction bar. X to the -2 belongs in the denominator as x to the 2nd. Y to the -6 also goes to the denominator as y to the 6th. Now you'll notice I don't have anything in the numerator. Remember, You always have to have something in your numerator. If the denominator is missing, that's fine. It has a denominator of 1, you don't have to write it. All right, but when the numerator is missing, you have to put the 1 there. That way I understand, oh, okay, this is a fraction. There's a 1 at the top. I know that this is 1 over those variables, okay? You've got to put the 1 placeholder there. So this would be our answer for problem number 4. 1 over x to the second, y to the sixth. For problem number 5, we have u to the sixth, v to the negative fifth inside our parentheses, and we're raising that to the negative second power. So again, we need to remember that for power to a power, we multiply the exponent, so it's like a distributive property problem. We need to take that negative 2 and multiply it by everything inside the parentheses. All exponents must be multiplied. So my u stays a u, but I need to multiply 6 times negative 2. I get negative 12 as my exponent. For v, we're going to multiply negative 5 times negative 2, and that will give me positive 10 as my exponent. Now I need to write my answer as a fraction. All positive exponents go in the numerator, all negative exponents go to the denominator. So here's our fraction. U to the negative 12, that's a negative exponent, so I'm going to bring it down to my denominator and write it as u to the 12th. V to the 10th is a positive exponent, so I'm going to write v to the 10th. This would be our answer for problem number 5. For problem number 6, we have 2v u to the 4th, and it's all being raised to the negative 6th power. Now you'll notice I'm missing some exponents. All right, I don't have an exponent for the 2, and I don't have an exponent for the v. Anytime you're missing an exponent, remember, there is a 1 there, they just don't write it, okay? So I'm going to go ahead and put a 1 for each of my exponents for the 2 and the v. Now I can go ahead and do that distributive property. Make sure you distribute the negative 6 to all 3 exponents, okay? Multiply all 3 of them by that negative 6. So 2 is going to have an exponent of 1 times negative 6, which is negative 6. For v, we'll do 1 times negative 6, which is also negative 6. And then for u, 4 times negative 6 is negative 24. At this point, we write our answer as a fraction, okay? So all negative exponents go to the denominator of the fraction. 2 to the negative 6th power is a negative exponent. That means that 2 belongs in my denominator as 2 to the 6th. V to the negative 6, again, another negative exponent goes to the denominator as v to the 6th. U to the negative 24th, another negative exponent needs to go to the denominator as u to the 24th. There's nothing in my numerator. Please put a 1 there, okay? There's always something in the numerator. Go ahead and put a 1 as your placeholder. Now this time we are not finished after writing our fraction, okay? Once the fraction is written, for this one, that was fine, okay? I didn't have any numbers that I could simplify, so I just left this the way it was, okay? This, however, has 2 to the 6th power. I can simplify that, all right? So again, I'm going to show you how to do that in your calculator. So anytime you're trying to do an exponent other than to the 2nd power, and actually you can do this for the 2nd power as well if you want to, but start out with the large number, the 2. So you'll type in 2 first. Then you will see that little arrow, roof, caret key along the left-hand side, okay? Go ahead and push that. That means the next number that you enter will be the exponent. My exponent is 6, so 6 will come next. And then just hit enter. Remember, enter means equal. All right, so you should get 64 when you type this in. Remember, that's 2 times 2 times 2 times 2 times 2 times 2. You're multiplying 2 by itself 6 times. All right, so we get 64. Now, that 64 belongs in the denominator, okay? Don't move anything. We've already written out our fraction. Our fraction stays the way it is, okay? Nothing gets moved up or down at this point. We are done. 2 to the 6th is just being simplified, but it still belongs in the denominator. So that means that 64 belongs in the denominator. The 1 stays at the top. I put 64 at the bottom with the v to the 6th power and the u to the 24th. This is our answer for problem number 6. At this time, go ahead and pause the video, try problems 7 and 8 on your own, and then come back to the video, press play, and check your answers with mine. For problem number 7, we had 5x to the 3rd, y to the 5th, and we're raising that all to the negative 2nd power. So the first thing I did was multiply all the exponents, including the 1 that's by the 5, even though they didn't write it. So 1 times negative 2 gave me 5 to the negative 2nd power. 3 times negative 2 gave me x to the negative 2nd power. And 5 times negative 2 gave me y to the negative 10th power. Once I've multiplied all the exponents, I write my answer as a fraction. All of them have negative exponents, so I put them all in the denominator. 5 to the 2nd, x to the 6th, y to the 10th, which meant that I needed a 1 at the top of my fraction. From there, because I do have a number in my problem, I need to go ahead and simplify that exponent. So 5 to the 2nd power, remember that's just 5 times 5, multiply 5 by itself 2 times. So 5 times 5 is 25. So the answer for number 7 is 1 over 25 x to the 6th, y to the 10th. Now for problem number 8, we have 5u to the negative 3rd, v to the 4th, and it's all being raised by the 2nd power. So again, the first thing I did was multiply all of my exponents by that 2, which included the 1 for the 5, even though it wasn't written in, okay? So multiply those first, we get 5 to the 2nd power, u to the negative 6th power, and v to the 8th power, because I multiplied all of my exponents by a positive 2. From there, I wrote my answer as a fraction, okay? All positive exponents went in the numerator, all negative exponents went to the denominator. So 5 to the 2nd belonged at the top, because it had a positive exponent. U to the negative 6th went to the denominator and became u to the 6th. And lastly, v to the 8th stayed at the top as well, as v to the 8th. One last step, I do need to do that multiplication. 5 to the 2nd power can be simplified. We know how to do that. So 5 to the 2nd is just 5 times 5. Again, that's 25. So 25, and it belongs in the numerator. If that's where your number was when you wrote it as a fraction, that's where it stays. So we have 25 v to the 8th over u to the 6th for our answer for number 8. And that's the end of our lesson on power to a power.